All right, this is just a short explanation for anyone who needs a recap or who maybe missed the initial explanation of enzymes. So in our notes, here we go. You can find this, all of this is in your book. So if you need a book, just talk to me. You can check one out. If you come up to the front of the room, let me know what book number you have. You can check out a book to look through this because this goes right along with the book. Things that we're looking for. We need to understand what happens to chemical bonds during chemical reactions. We talked about that earlier. We're going to talk about energy change and how energy is involved in chemical reactions and what role does enzymes play, and then what affects their function. All right, so we need to start with a little bit of vocabulary. I'm going to leave it to you to push pause or even look these up in your book because I only have 15 minutes at a time recording. So I'm just going to remove these so you can see them. You push pause where you need to push pause to get the vocabulary. But chemical reaction and reactant and product are all review. So a chemical reaction, we're just changing chemicals from one thing to another. We start with reactions and reactants, and we end with products. Now we're still working with chemical reactions, only this time we're talking about chemical reactions that require an enzyme. So some new words are going to be activation energy, which some chemical reactions require an energy input. Like let's say if I was going to start a match, all of the potential energy in that match head is ready. It just can't start itself. But as soon as I add friction, this is energy needed to get the reaction started. As soon as I add that friction, then all of a sudden, poof, that match head is lit and it keeps going. Okay? We're going to learn that enzymes don't actually supply the energy the way friction does. They work in a different way. But we have to overcome that activation energy in order for these chemical reactions to happen. Because otherwise, this activation energy is so big, it won't happen on its own. Then we need to understand what a catalyst is. A catalyst is just anything that speeds up the rate of a chemical reaction. So an enzyme, in this case, is a catalyst. It's going to get things going. I always think of someone who's a social catalyst. A social catalyst is someone who gets the conversation going, who goes around the room and talks to everybody and gets things going. That would be a social catalyst. We're going to be talking about a chemical catalyst, and that chemical catalyst is an enzyme. So an enzyme is a protein that acts as a catalyst. It speeds up chemical reactions. And then a substrate is just a special word for a reactant that binds to enzymes. So we learned that we have reactants. They rearrange themselves into products in a chemical reaction. If those reactants are binding to an enzyme, we just have a special name for them, a substrate. All right, you can check out the example in your book, but the example in our book is basically showing us a real life situation where an enzyme is necessary or we won't live. So in our blood cells, or in our cells, we get rid of carbon dioxide. Our cells, when they're creating energy, create carbon dioxide as a waste product. And if that builds up in our cells or in our bloodstream, we get really sick. So our body needs to get rid of it. However, carbon dioxide doesn't necessarily just dissolve in water really easily. Otherwise, like if you blew into a water bottle, right, you'd all of a sudden have bubbles in your water. But just because carbon dioxide is next to water doesn't mean it will dissolve in water. So what happens is we have this hybrid chemical reaction where carbon dioxide and water both bind to an enzyme. Now, that enzyme it's way easier for that enzyme to change the shape and break those bonds and rearrange these two chemicals to create something called carbonic acid. Now, this dissolves super easy in our blood, and now we can take that carbon dioxide in this new form up to our lungs. And then we basically reverse this reaction with a new enzyme and then get rid of the carbon dioxide in our lungs. And in order to really understand this, there's a video. You won't be able to click on the screen right now, but if you go to my YouTube channel, this video on carbon dioxide entering the blood, enabling the blood to carry carbon dioxide to the lungs. That will explain it a little bit more. But the whole idea behind this is that this chemical reaction wouldn't happen fast enough if there weren't an enzyme there. And can you imagine if we didn't have that enzyme? Carbon dioxide would build up in our cells, it would build up in our blood, and we would get really sick, probably even die. Now, one thing that we need to understand when we're dealing with enzymes or any chemical reactions is that energy is released or absorbed whenever chemical bonds are formed or broken. Okay, so this means that chemical reactions involve changes in energy. And we have two different changes. Sometimes chemical reactions release energy and sometimes they absorb energy. So, for example, when we are digesting food, we are breaking bonds to release energy. So when we do that, these are spontaneous reactions when they release energy. Now, this doesn't always mean that they're going to happen without an input, like the match. Again, go back to that example. When I light the match, that's releasing energy. It's releasing light and heat energy. And we call it spontaneous. It doesn't mean that it's going to happen without that input of energy. It just means that once it gets going, it goes on its own. And then there are chemical reactions that absorb energy, that require energy. So they won't occur without energy. And that's why we eat. We have some chemical reactions in our body that need energy, not just enzymes. They need energy. So in order to stay alive, organisms need to carry out reactions that require energy. Every organism needs a source of energy to carry out chemical reactions. So in other words, I don't know if you remember this chemical from 7th grade, but we're really making ATP for this. So plants get their energy from the sun to make ATP, and animals we get our energy from eating other plants and animals and making ATP. Now that's something kind of separate. And we'll come back to that when we get to cells and we start talking about how our bodies make energy. We're going to spend some time on some spontaneous reactions, except they aren't completely spontaneous. Chemical reactions do not always occur spontaneously. That's a good thing. Otherwise, your paper would just burst into flames. Because cellulose, which is what your paper is made out of, burns in the presence of oxygen to produce heat and light. So there's oxygen in the air right now, and your paper isn't starting on fire. That's because it requires an activation energy, something to get it going. However, once you light that paper on fire, it's going to keep burning. Does that make sense? All right. So we're getting closer to the whole idea behind how enzymes work. So here's what happens. We start over here with our reactants. This is their potential energy right here. So this is the reactants. However, we want to get down to the products. We want go through this chemical reaction from beginning to end. However, in order to do it, there's this great big hill in our way. And that great big hill is what we call activation energy. The amount of energy needed to get that reaction going. And once you get over the hill, whoop, then it just finishes itself off, right? It just goes all the way to the product. Now here's what happens. Let me see if I can pull up my pen. How an enzyme works is it doesn't supply that activation energy. That's not how it works. What it does is it makes the chemical reaction happen easier. So what it does is it lowers that activation energy. So it becomes that great big hill all of a sudden becomes just a little mound. And that is with an enzyme. Sorry, I'm not very good at writing with my pad, but hopefully you can see the difference. So this is the activation energy without an enzyme. So like that carbon dioxide dissolving in our blood, it probably isn't going to happen on its own. It needs too much energy to happen on its own. However, all of a sudden we involve an enzyme and it becomes easier. So this chemical reaction starts happening 250 times faster than without an enzyme. So this is a really important table or graph. I really want you to get to know this graph. Anyway, and there's also a video. If you see this is on my YouTube channel. It explains the same thing, how activation energy works. It explains this table and how enzymes just make the chemical reactions happen easier. It requires less energy. And when it requires less energy, it happens faster and easier, and that's why enzymes are catalysts. That's why enzymes make chemical reactions happen faster. So in order for our bodies to overcome this activation energy, our cells make catalysts. And catalysts work by lowering the amount of energy needed for the reaction to happen. And what do we call that amount of energy needed for the reaction to happen? We call that activation energy. So catalysts work by lowering the activation energy. They make it easier. So here's the example I like to use. Let's say you've got this, I think it's a hazelnut, whatever it is. You've got a hazelnut. If you tried to crack open that hazelnut with just your hands, no tools, no help, it would take too much energy. There's no way you would get that hazelnut cracked open with just your hands. However, you use a nutcracker, you wedge that hazelnut in there and squeeze the handles, and all of a sudden that hazelnut cracks open super easy. That's how an enzyme works. This is trying to crack open that hazelnut without a nutcracker, but you use a nutcracker and all of a sudden it's super easy, and you could do it over and over and over all day, right? And that's how an enzyme works. And I want to point out another thing too, is that this nutcracker doesn't get used up. It's a tool. An enzyme is just a tool. It can be used over and over again. The catalyst doesn't change during these reactions. It doesn't get consumed. It doesn't get used up. It can be used over and over. So as soon as it changes one set of chemicals into another, it can go back and do it over and over again. So enzymes are kind of like a tool that make it easier for chemical reactions to happen. And since that makes them happen faster, we call them a catalyst. So enzymes are catalysts to make chemical reactions happen faster. There'll be a second video for the second